Firstly, what is heat? What is thermal energy? The fact is, it is the sum total of all of the kinetic energy of the particles in a material, whether it's the air molecules bouncing around in here or the carbon atoms vibrating in a diamond. When you add up all of the kinetic energy of those particles, you have the heat energy. According to the formula, 1/2 mass times velocity squared, 1/2 mv squared. So when you add heat to a system, you obviously are not increasing the mass of the particles, you must be increasing the velocity. As you continue to add heat, the velocity can be so great that solids fall apart, they melt. Keep adding additional heat, and the liquid is no longer stable, and it vaporizes into a gas. The other principle we have to cover is one that can actually confound a lot of physics students, and even a few professors. It's related to that dirty word, entropy. Now, entropy has a lot of subtle implications, but for our purposes here, we can pretty much just substitute the phrase, the tendency toward equilibrium. The fact that when you have a system with different energy levels in it, they tend toward an average as opposed to diverging to higher and higher differences between the energy. Entropy is that tendency toward averaging. For example, if you have a mountain with all the rocks and boulders and soil piled way above the surrounding terrain, you have a lot of potential energy in that system. And because of entropy, given enough time, hundreds of millions of years, that mountain will eventually erode down to the surrounding terrain level to be at the exact same distance from the center of the Earth. Entropy always wins.